I'm curious, when we're talking about de-extinction, are we really bringing these animals back from extinction? Or is it like, can you explain that side of it to me? Because it sounds like you said earlier, kind of sci-fi-esque, where it's like literally almost
cutting
like playing
edge,
God.
cutting
Almost.
edge.
Well, it's a good point. We should take a step back and just explain how de-extinction works.
Okay,
right?
cool.
So we talk about functional de-extinction. This is the idea that we can recreate the function of an animal that was lost.
Yep.
And the way you do that is typically by phenotypically or like physically recreating that animal, right? So de-extinction is this idea that you can go back in time and you can find specimens in the landscape. Woolly mammoths did us a favor. They died in freezers, right? So there's really nice preserved specimens. You get beautiful DNA from these.
That's cool.
Tasmanian tiger didn't go
maybe some in a museum or something.
Then we found beautiful specimens that were a museum curator preserved a pup in ethanol. Beautiful.
That's what it was.
Yeah.
Yes,
Whoa,
dude,
yeah.
Crazy. So, but you're looking for this older.
We're trying to find DNA.
Yeah,
but it's not in the same way that you think of Jurassic Park, where we're going to extract DNA and use that. Yeah. We're just sequencing it. So we're creating a digital copy of their DNA. It tells us exactly what the base pair order of their entire chromosomal structure was. That then allows us to use our sort of AI-powered genomic analysis software and say, what is the closest living relative to this animal? And it tells us, in the case of the mammoth, that's an Asian elephant. Thylacine, that's a little mouse-sized marsupial called a fat-tailed dunnart.
Wow.
That's crazy, right?
That's it's like something only AI could tell you. It's like,
and dodo would be most closely related to a Nicobar pigeon, which is a beautiful pigeon from the Pacific.
Cool.
And then what we do is we use that same software package in order to tell us, where are these animals the same and where are they different?
Fascinating.
Yeah. More importantly, where is it that every time you see this animal, this woolly mammoth or this thylacine, it's always the same? Because that's really critical. That tells you, that's highly conserved. That's important to the species. We then select those specific genes that would take a Nicobar pigeon into a dodo or elephant into a mammoth, and then we bring those into the mammoth the elephant genome or the dodo or the pigeon genome in order to create a cell line that has as close to the DNA sequence of the original as possible. You're not going to get to 100% with today's technology. But what we're doing is trying to pick those key physical traits that result in key functions. So to your earlier question, when we make an embryo and that becomes an animal, is it the exact replica of that lost species? No. Is it as close as we can get? Yes. And is it going to perform the exact functions we need it to in the ecosystem? Because remember, we're talking about putting the block back in the ecosystem.
Got it. So that's kind of
Is it, Grant, or is it not? It's about as close as it can be.
And what's interesting is if you look at one mammoth that comes from, say, Alaska from 10,000 years ago and another mammoth that came from Siberia 250,000 years ago. Those are the same species. Yeah. But their genome is vastly different. Yeah. Like there's huge variability.
They've changed over
this
time.
This idea of always trying to exactly replicate what was lost is sort of a fallacy because best you could do is maybe take an average of everything that was lost and make that copy. It's not the same, though,
Oh, that is fascinating because it changes and adapts over time. So you're kind of saying even woolly mammoth. Which one are you talking about?
It's easier for people to think that nature is static.
Yeah.
It's easier for us. We even talk about habitat restoration. Yeah. There's this amazing guy, the guy that led the Yellowstone wolf reintroduction, his name Mike Phillips. He says, restore to what? He's always got that idea.
Yeah.
In the U.S., we say restore to 1492. Right? This idea that what was the U.S. before Europeans came?
Yeah.
But also, humans were on the landscape well before Europeans got here, and humans were having an impact on that. But also, without humans, nature is going to be this dynamic process.
Yeah. So, it's never. That's really good to think through when you're kind of defining it. It's like, hey, it's not just one exact thing or the exact moment. Because you're talking about different animals coming in, like horses coming in early on, and that changes the landscape. There's
and I like that North Star of like we're just trying to put the pieces back into the Jenga puzzle. It doesn't necessarily have to be an exact replica because that's a bottomless question almost. It's like how do you even get to that?
And we talk about engineering for tomorrow, not engineering for yesterday, because yesterday's gone. Climate's different, right? We've all talked about that plenty, right? There's much more human development on the landscape. So we have to create species and ecosystems that will thrive in tomorrow's climate and tomorrow's, disruption that humans will present.